This question is called the Monty Hall problem, and it's a very famous question. So I doubt they'll ask it in an interview, but they might ask a variation of this question. It was in some movie. I think you might have, maybe you've seen the scene, but it says the Monty Hall problem is a probability puzzle based on an old American show, Let's Make a Deal. The problem is named after the show's host. Suppose you're on the show now and you're given the choice of three doors. Behind one door is a car, behind the other two, goats. You don't know ahead of time what is behind each of the doors. You pick one of the doors and announce it. As soon as you pick the door, Monty opens one of the other two doors that he knows has a goat behind it. Then he gives you the option to either keep your original choice or switch to the third door. Should you switch, what is the probability of winning a car if you switch? So let's break this question down because it's like pretty long. So in a long question, you want to break it into parts so you can understand the whole question. So it says we have three doors. So we have door 1, door 2, and door 3. Behind one door is a car. So we can say like, oh, this blue means it has a car behind it, and this red, other two has goats. So we can say like these two are like the losing doors, unless you really like want to get a goat for some reason. You don't know ahead of time. What is behind each of the doors? You pick one of the doors and announce it. So let's say we pick, I don't know, this one, right? The first door, whatever. We don't know what's behind the door, obviously. We're just going to pick randomly. As soon as you pick the door, Monty opens one of the other two doors that he notices it has a goat behind it. So we pick this door. Then the game show host will open this door for us. And now we know that this door has a goat behind it. Then he gives you the option to either keep your original choice or switch to the third door, aka the last remaining door. Should you switch? And what is the probability of winning if you switch? Now, in this case, right, if we switch to this other door, we end up losing. But we should first backtrack a little bit. What is the chance of us winning this game if we just pick our door and forget? We don't take any other deals or anything like that. What's our chances? Well, obviously, if you have three doors and one of them has the ideal outcome, then you have a probability of winning, given no switch, of 1/3. Okay, what if in this scenario we ended up switching? We switch to this door, we end up losing now. So in this case, switching wouldn't have been good, but we don't know when we can have the good case of switching or not. We just know that we're just going to switch or not every single time. So let's say we picked, so actually, let's say we picked the red door and we switched. What would happen? We end up winning now, right? We picked the wrong door, but after we switched, we now get to the correct door. So it's interesting. We picked the wrong door at first. We switched and got the right door. Nice. So that cancels out the first case where we ended up switching to the wrong door. If we picked this door initially, and then the game show host reveals to us that the other door is like the goat door, other goat door is this one now. We picked this one initially. Again, if we switched, we get to the correct door. So as you can see, when we pick the wrong door initially, the other wrong door gets revealed, and then we can switch to the correct door with probability 2/3, right? Every time we pick the wrong door, which is a probability of 2/3, we pick the wrong door initially with probability of 2/3. Then the game show host reveals the other door, one of the other doors that had the goat. Now when we switch to the correct door. So what I'm saying is the probability of win given switch is equal to the probability of picking wrong door initially. Right? Now we win the game when we pick the wrong door initially, the other wrong door gets revealed, and we switch to the right door. If we pick the right door initially, and then one of the wrong doors gets revealed, we switch to the other wrong door. But there's two ways to pick the wrong door, and there's one way to pick the right door, and therefore you're better off switching with the probability of 2/3 to win if you switch.